My name is Prajesh. A quick introduction before we move on to the technical session today. I work as a vice president at American Express India and work in the payment network division. So just a very quick, brief session before we get on to the topic today. American Express, as all of you know, is one of the largest payment companies in the world. And many of you know American Express is a company that issues cards, that's in the finance industry. But really, at the core, we are a technology company. We deal with the best of the cutting edge of technologies, whether it's related to distributed computing at scale, or cloud, or mobile computing, machine learning, and AI, you name it. So many of our technical problems that we solve here at American Express, we solve it for scale. Now, just to give you some context into that, I would like to talk about some numbers that you get an idea. So we are a very large scale transaction processing company. We do payments volume of more than $1 trillion US dollars per year. And that, if you wonder what that number is, it's more than the annual GDP of 90% of the countries on this planet. We have more than 100 million cards issued worldwide. We are a company that has been innovating for the past 160 years, and we are, $40 billion by revenue company and growing in double digits. Now, also to talk about some of the other interesting things about American Express. We are one of the most respected brands in the world. We are, in fact, in the top 25 companies in terms of the most admired company, in terms of the brand value, and also the best company to work for. And specifically, when I talk about American Express India, we are consistently rated as one of the best companies to work. In fact, in last year, by a survey by Economic Times, we are rated as the third best company to work for in India. And we are also rated in the top 15 companies for women to work in India by Great Place to Work Incorporated. So before I invite our technical speaker of the day, I would like to say that at American Express, we are extremely committed to building and sustaining a very highly inclusive culture. And for us, this is very, very critical. We are very deeply committed because we believe it brings about innovation, and it brings the best out of people, best out of our employees, creates a very inclusive environment where there's no fear. Everybody is willing to experiment. Nobody's afraid of failures, right? And we believe diversity, especially gender diversity, is extremely key to achieve that. So we are happy to continue our commitment to Grace Hopper conferences and activities in India. And with that, I would like to invite our speaker to talk about cloud and AWS. Thank you.
Thanks, Pitan. This is Jyotsna, and I'll be taking the technical session today. First of all, I would like to introduce myself. I'm working as senior technical consultant at Intel, and I mainly focus on distributed parallel computing and also on AI. Overall, I've been working in the industry for 16 years, and my main contribution is towards the research of parallel systems and also on the AI side, distributed computing, specifically on distributed deep learning. So with that, I would like to share my screen so that I can share the content here, and we can go through the content completely. Please let me know when you're able to see my screen. So I would like to talk about introduction to AWS, which is a cloud platform, and where you can develop your application and deploy your application using the AWS services. And there are some development tools which you can leverage to make your code high performance on the AWS cloud. So along with me, Krishnaveni Reddy, she is a senior project manager at Fidelity. We have worked on this content and I'm presenting that on behalf of Krishnaveni also in this. So in today's agenda, I will talk about what is AWS, benefits of AWS, services provided by AWS, and how to use it to AWS, along with some AI and ML tools which you can use for your development and deployment. So AWS is about Amazon Web Services, which is a platform which offers a flexible and scalable solution for cost-effective manner where you can do a cloud computing and develop your own solutions. So this comprises of multiple aspects from AWS, starting with global infrastructure, cloud computing, serverless computing, and deployment on the cloud. Compute is a bigger chunk, which we are going to talk about, and how you can leverage the compute instances available from AWS. Storage is big aspect where you can keep your data and do the analytics on top of it. Security is important, and AWS is taking utmost care of it. And then you also have networking and databases available as service on AWS. So when we talk about AWS Global Infrastructure, how it is laid out is it's being deployed in terms of regions. There are 16 regions worldwide. Basically, each geo has its own defined as region. Let's say you're working on South America or North America, that would be one region. And if you're working on India or Southeast Asia, so India would be another region where Mumbai is a specific location where the AWS services would be deployed. So you can choose from the region, and this region will have multiple services available. Not all the region will have all the services, but AWS try to have all the services on all the regions. And the cost is depending on the geolocation. So your cost on, if you choose US region, so it will be based on US economy and the prices would be in dollars, whereas when you choose a region based in India, you will be charged in the Indian economy. And the region also plays an important role when it's divided between the availability zone. So your multiple AWS servers deployed in availability zone within the region. So if you select a region, let's say in India, so you'll have two availability zone, which make sure that whenever you copy your data to AWS cloud, if one of the server goes down, the nearest availability zone has a copy of it, and then it's a fail safe for you, so that there is no data loss or there is no compute time loss what you're when you're deploying your solution to AWS. So it's important to choose a region where you work with, where you are currently living, and how effectively or how with less latency you want to access your data. So region plays a major role there. And then there are 50 plus locations where they have cloud front distribution on the edge locations, which make sure that the latency of your data when you get it is lower and lower within the region when you choose it. When we talk about cloud computing, what is cloud computing? It's all about your computer processing resources which are shared, and then your data and compute power is available for you on demand when you want to do computing. And how AWS has defined it, it's like on-demand delivery of compute power which they provide. Your database storage, your applications availability, and all the platform available via internet, and you pay for use whatever you're using, you're paying the price only for that. So in this particular aspect on the cloud computing, you can deploy your applications, you can choose the platform where you want to deploy your application and use the platform, or you can also leverage the infrastructure services which is available from AWS on the cloud environment. This can be accessed from multiple fronts. You can use it from your desktop, laptop, your mobile phone, or your tablets. So you can do the cloud computing using any of the devices. Let's a little bit understand more about the cloud computing model. So you can use it in three different ways. One is infrastructure as a service, where all this compute capability, um, this is called elastic compute, or elastic block storage, which is available infrastructure as a service to you, which you can choose it from, and then you can deploy your application on top of it. Apart from them, there is another one called platform as a service, where AWS manages the underneath infrastructure for you, but where you can deploy your platform itself to as a service to the user to use it. One of the example could be EMR, which is Elastic Map Reduced, which is deployed from AWS, which you can use it for solving your map reduce problems, or maybe a RDS. RDMS databases, maybe from Oracle, maybe from MySQL, or there are some multiple platforms which is deployed from Microsoft, let's say Office 365 and all. So that's called as software as a service. So completed product which is running on AWS, which you can choose and use it as a service. So let's say when you go to Office and open your Office, you access your web-based email. This is nothing but a software as a service which is running on a cloud platform. There is another aspect to it as a serverless computing. This allows you to build and run your application without thinking about a server and how much you pay for. So this is also referred as a function as a service. So some of the example is Amazon Simple Storage Service, which is called S3. I will also take you through the couple of services which are important, which you can make a note, and when you develop your application or your prototype, you can choose one of these. AWS Lambda is one of the ways where you can write your application, and this helps you to execute and deploy without your intervention on its own. Similarly, there is a database services available from Amazon. It's called DynamoDB, and also notification services which are available as a serverless computing. So as and when there is no work going on, you're not being charged for it. Cloud computing deployment models, you can deploy it on cloud in three different ways. You can choose it or fully deployed on cloud, where all parts of your application run on the cloud. You can also choose it to have it hybrid model, where you can have your own infrastructure which is connected to the cloud, and you can choose your application to run between your own infrastructure and a cloud-based platform. So this could be a hybrid possibility of deployment of your applications. The third one is on-prem. So when you're deploying your resources on premises using visualization and resource management tool, this is also offered by AWS, and this is sometimes it's also called a private cloud, which you can choose and own it. What could be the benefits of using AWS is it's very easy to use, and it has a very good GUI where you can choose the services based on the software as a service or infrastructure as a service, and then you can deploy your own management console, and then you can use any of the services on the AWS hosting platform. It is also very flexible in terms of choosing the operating system. So you can choose either Linux or Windows, whichever platform you want to. Programming languages, multiple programming languages supported their web application, and you can choose databases which you'd like to use it for your application. It also has a virtual environment that you can load the software, so you can also have containerization, which you can choose it and use it for deploying your application. It's very cost effective because you're only paying for the compute power storage, and you're not even paying for the entire rest of the infrastructure maintenance and everything. There is no a long-term contract or upfront commitment. You're paying for what you use for. The other benefits are it's very reliable because they manage a lot of redundancy, as we spoke about the availability zone. With that, they try to make sure that all the infrastructure is up and running. Even if there is a one failure in one zone, the data is available on the another zone. So this is a fail-safe mechanism is inbuilt. and it's highly scalable and high performance. Why I would like to say it's scalable, because it also have elasticity built into it. So when you're deployed your application, it has a lot of load. Automatically, if you're using elastic load balancing, it will take care of routing your request to multiple servers, and it can also incorporate increasing the your server farm size or reducing it based on the request which you are getting. So, and it's also high performance because underneath infrastructure on the hardware side, they have taken utmost care of using all the high end servers which can give you high performance compute. If you are talking about EC2 instances, which is powered by Intel processors, so which is a really high performance computing processor which you can use it for your compute applications. It's very secure. It's end-to-end approach about towards the security. Even hardening the infrastructure is being done even at the physical, operational, and software level as well. So when you go to the AWS website and try to understand the product and services, you can see something like this, which is like multiple products and multiple services. So sometimes it takes time to understand and choose from. So I'll give you a little bit overview of the important ones which you can choose and use it for, and then this will make you much more easier for you to use it. So this are multiple categories which AWS products and services are categorized under. You can choose it for compute capability, you can choose it for storage, different kind of databases are available, and you can also choose it for management tool, messaging, and analytics. Apart from this, you can also have application services. You can also have developer tools. I'll also talk about one or two developer tools which you can use it. There are a couple of them which is already available on AWS website in the marketplace. Apart from that, you can also get your own tools and you can install it and use it on your application development. So it offers a wide range of different cloud-based products which you use it for your networking, mobile development, or enterprise application development, and you can pay as you go for price model. Let me give you a little bit more detail about the compute category. So EC2 is Elastic Compute Cloud, which is flexible service and it's a resizable. So when you choose a number of EC2 instances, when you choose elastic bound, it can reduce and increase the size of compute capacity, and which are also equivalent to your virtual servers. So you can use EC2 is powered by various processors. So I would like to recommend C4, C5 instance. C5 instance has the latest and greatest processors from Intel, and just 2 days ago, it has launched the Xeon Scalable Server second generation processor, which is Skylake, which is just 2 months old into the market, and it has very high-end power, compute power capability, which you can use it. You also have a ECS. You want to use a containerized service. So you want to deploy your applications in the containerized environment, and which can be deployed on your EC2. You can use it ECS, Elastic Container Services. And then you also have elastic load balancing. I mentioned that if you have multiple requests coming in and you have deployed multiple EC2 instances, depending on the request coming in from regions, it will load balance the EC2 instances and reroute your request to the instance which has lower load. So it helps you to reduce your time when you try to run your application and deploy it. Lambda is very important aspect. This allows you to run your code without provisioning or managing any servers. So you pay only for the compute time what you consume. So when you generate your Lambda function or Lambda classes or Lambda application, you give it to AWS Lambda, and it will on your behalf, it will manage it, it will execute, and it will be running it. So with this, you can have you can run your code virtually any type of application or a backend service with definitely zero administration on your end. So just let me give an example what kind of web server or EC2 instances you would like to have on AWS. So AWS Cloud is this, and you have, let's say, multiple EC2 instances which you're trying to deploy your application. So you will have a elastic load balancer here, which will forward your request to multiple of these EC2 instances. You can also have a Docker ECS, Elastic Containers service inside your EC2 instances, which you can use it. And this group can be auto scaled using Elastic Load Balancer and auto scaling capability within AWS. Let me give you a little bit of more detail on EC2 instance. This is powered by Intel. This is called C5 instance. Within C5, you have multiple generation of Intel processor. One is Skylake processor, Xeon Scalable processor, and then the Intel second generation of Skylake, which is Cascade Lake, which is also available on EC2 C5 instance. The advantage using this is you can take the advantage of all the hardware capability of AVX 512 advanced vector extension, and in the second generation of Skylake processor, you can take advantage of vector neural network instruction set, which is available as a part of hardware feature in Cascade Lake, and which allows you to accelerate your inferencing capability at the hardware level. Just to give you an idea, different generation of Intel processor available into C4 and C5 instances. C4 instance has a previous generation processor called Haswell. When we deployed Skylake into C5 instances, you can see clearly 2x performance improvement because of the AVX 512 capability, which has been put in inside the Intel processor. So when you run it, your application, let's say you run your application on C4 and the same application you would like to deploy on C5, and if it's taking advantage of vectorization, definitely you will have twice advantage at the performance front. So these are some of the instances: C5 large, C5 X large. So the recently C5 X large, 9x large, which is introduced. This is Cascade Lake, and see, it's not mentioned in this table. And C5 24x large is also high-end Cascade Lake, which is being introduced here. This is very important for you to understand. This is very helpful when you do distributed analytics, because it has a very good capability of having networking capability and also high bandwidth memory. So that the price advantage, what you'll have is 25% of price to performance improvement on your C5 instance over C4 instance. And then additional memory, you can see the memory configuration is also going higher and higher, up to 144 gigabytes RAM available with C5 instances, which you can use it for your application deployment and running. To give you an idea about the workload on the performance side, this is comparing in C4 and C5 instances. There are multiple algorithms and multiple applications. This I'm quoting from high performance computing. So these applications maybe on molecular dynamics, LAMS, or GROMACS, when they have run it on different generations of EC2 instances, you can see times performance improvement running the same applications over C4 instances. There is also advantage of TCO, total cost of ownership is going down, and with multiple applications deployed, only a couple of them has very minimalistic disadvantage over the cost. But you can see large amount of applications is getting more and more price performance improvement, up to 60% when they try to deploy it on C5. So AWS also allows you to take advantage of storage, Amazon Elastic Block Storage, EBS, which can be attached to your EC2 instances, and where you can keep data. Apart from this, there's also Elastic File System. So this is very simple, scalable file system for Linux-based workload, which you can use it on AWS Cloud. And this is designed to provide massive parallel shared access to thousands of Amazon EC2 instances. So when you're deploying, you can use this. This can be used as a mount point, and then you can achieve a high level of aggregate throughput with consistently low latencies while accessing the data. There is also a simple storage service, Amazon S3, where you can use it for storing all your object or files or any kind of data over the internet. This is the simplest form of storage which is available from AWS. So let me give you a little bit example on how storage work. Let's say you have multiple EC2 instances, and EC2 instances are attached to your EBS, Elastic Block Storage. And then there is a mount EFS to mount to your file system. And then these are, all of them are connected to file system which is already outside of it, which is in the NAS. So when you use all the data from EBS for compute, you can use it on EBS. And then after that endpoint, after certain time when you're not using the data, it can go to the S3 bucket. And then even after some time when it becomes obsolete, you can even want to use it for archiving purpose. You can use a Glacier as a vault where you can store your data for a longer term. On the database side, there are multiple possibilities which AWS provide with relational databases, which has predefined schema and relationship between them. They also support your ACID transaction, and they maintain referential integrity and data consistency. Some of them is, example is Amazon's Aurora, MySQL, Amazon RDS, and MariaDB, Oracle, SQL Server. So all these are available for you to use it as a service. And then the key value database, it's highly optimized for key value pairs in a large volume, and you fetch the data in milliseconds without any performance overhead or scalable limitation in the relational database. AWS also provides you analytics as a service, so which you can use it in the most cost-effective manner. Analytics services that run on data lake as a platform, and the purpose, this service is proposed to build a wide range of analytics use cases such as interactive analytics, big data processing, Apache Spark and Hadoop, and real-time analytics as well. So Amazon Athena is one such service which makes it easy to analyze your data directly on S3 and Glacier using SQL queries, right? You can start SQL queries instantly, and as you get your results in seconds, you can pay only for the query to run, and then you can use S3 for defining your schema and start querying using your standard SQL. Amazon EMR, it's like Elastic Map Reduce. It's available as a service which you can use it on Spark or Hadoop framework, and this is a managed service for you. So you can use it. You can process a vast amount of data in cost-effective manner. So Amazon EMR supports 19 different open source projects which you can choose from, including Hadoop and Spark and HBase. Amazon Redshift it's available for you to run complex analytics queries against the petabyte of data, and this is going towards the exabyte of structured and unstructured data in S3, which you can use, and you can run your SQL queries directly on that. So it has a very good scalability. Apart from that, yeah, Amazon Kinesis is available for IoT telemetry data processing. You can do application log analysis, and then you can respond in real time instead of having to wait until all your data is collected before you process. Last but not the least is Elasticsearch services from Amazon. This is operational analytics allow you to application monitoring, log analytics, and clickstream analytics. This allows you to search and filter and aggregate, visualize your data in real time. This is very important, and the latencies are really less, so everything you can do it on real time. This has a very good availability, scalability, and security at the production and workload requirement. So, any questions? So how do we use AWS services? You can choose it from the website, and you can see here this EC2. You can choose one of these instances from here, and then you can deploy it. You can use your username and password, and then you can use it. Excuse me, any questions? You can also, I'm hearing some background noise. Any questions? Questions, Q&A, I'll take it at the end. Probably I'll just cover the content now. we also have a time for it. So when you want to use AWS, you can also use command line as option as interface. So you can use Linux shell command, Windows command line, or you can also remotely use it using PuTTY. You can do SSH to EC2 instances, and then you can get into the login, and then you can use it from PuTTY as well. Let me talk about a little bit of process and tools for application optimization on cloud. So when you write any application, you would also like to have optimized version of it so that you will have cost effectiveness when you use cloud. What you do a performance benchmarking your application. You find the hotspot where your application is spending most of the time. You investigate and root cause from within the hotspot, and then you modify your application to reduce the hotspot, and then again you do the performance benchmarking. So this is a process which you run through iterative process. And if any tool can help you to do performance optimization or a performance or your application development on cloud. So Intel has one such tool called Intel Parallel Studio, which you can deploy it on EC2, and then you can use it from design phase to build, debug, verify, and tune it for your application performance. So it has different parts of it. So you have build tools, which is having very highly optimized Intel compilers for C, C++, Fortran. We have highly optimized libraries for math kernel, Intel MKL library, for data analytics acceleration library, Intel DAL. And there is also Intel distribution of Python, which is high performance Python, which is you can use it for your AI or ML application development. You also have analysis tool. Once you have written your application, you would like to do performance analysis. So you can choose Intel V2 amplifier to do profiling for your C, C++, Java, Fortran, or Python code, or mixed code profiling, and then you can find a hotspot. You also have an Intel inspector to find out if there are memory issues or any threading issues in your application. You can debug using it. Apart from this, there is an Intel Advisor. As I mentioned, the EC2 is powered by Intel scalable processor, which has advanced vector extension. And if you're not taking advantage of this vector extension, you're losing performance on the table and you're paying for it. So this tool helps you to understand how much your code is vectorized and how much you're taking advantage of this vector instruction. If you're working on a distributed environment, you definitely would like to have scale aspect to it. So Intel has its own cluster tools, to cluster tools, and high performance library called Intel MPI library for scaling. And you also have a analysis tool called Intel Race Analyzer and Collector for message passing interface applications. And you also have a cluster checker, which you can use it on AWS. So how do you install it on AWS in EC2 instance? Is very simple. When you get into AWS EC2 instance, you download the product, or if you have downloaded product, you can just copy it over to EC2. You run the installer and then just use it. This is available for free for 30 days evaluation, and each and every feature is available for this tool. Let's talk about a little bit of the tool for higher performance for your development and deployment. So there has been survey done and to find out which is the highest used language while application development, which has the highest growth. So Python is one of them, and this is the basic language which is required to write most of your AI or ML applications. And it is notorious for not having performance because it's not a compiled language, it's an interpretive language, and it has a kind of global interpreter lock on top of it, which doesn't allow you to use a lot of parallelism underneath, which is being given by the hardware. So when you write your Python application, it is 1,000 or 100 times slower than the same program which you have written in C language. So Intel has taken a goal to give the flexibility and the advantage of Intel hardware to use it from the software layer, and that's why Intel has put in efforts to make a high performance Python. This is called Intel distribution of Python, which you can download and use it on EC2. How it brings the performance underneath in your Python application is, uh, I have spoken about the performance library from Intel, Math Kernel Library, Data Analytics Acceleration Library. These are the libraries which are plugged in underneath Python, and these are the libraries which are bringing in all the possible optimization done on a different generation of hardware with respect to the number of cores available, with respect to the vectorization capability, with respect to the threading aspect. All of them has been taken care, and a lot of the algorithm are handwritten, hand coded, even at the assembly level from Intel engineers to make sure that you get the best performance out of Intel hardware. What kind of performance implication you can see? It's like you when you run it, this is the comparison which we have done with the stock Python, which is normal Python, which you get it, and Intel distribution of Python. And this we trying to achieve the performance as you try to write a code on C or native language. You can see the performance of stock Python is, let's say, 50% and less than 50%, where C compared to C language, Intel Python is able to achieve almost 100% performance improvement when we talk about linear algebra algorithm deployed on it, right? So if you're writing any applications using NumPy, SciPy, scikit-learn, you if you use Intel distribution of Python on Intel platform, you will get the best performance out as close as to C performance. To give you an idea about the umath function, if you were processing on array to array or array to scalar or exponential function, you can see that stock Python is less than 10% performance compared to C, whereas Intel distribution of Python brings you closer to 87% as you write this code in C. So people are thinking about deploying even Python code on the production because of the high performance Python available now. What is inside Intel distribution of Python is when there are performance library which is powering this Python distribution, specifically NumPy, SciPy, or scikit-learn, which you're using it. It is being powered by Intel MKL and Intel DAL, and DAL for Pi is one package which you can use for. This is pre-built and accelerated package. You can directly, if you want to see what all packages are optimized, you can say Intel distribution Python package. You can get the package list completely. This is also available on 2.7, 3.6, and 3.7 Python version. You can use it different variant to download it. Conda, Pip, app, get, yum, and Docker Hub is also available to use it. You can also download standalone, and then you can use it for your Windows or Linux. You can also get it from Anaconda channel. You can say add Intel channel, and you can get it Intel distribution of Python. We are also upstreaming this performance optimization to Anaconda. So let's say if you're using NumPy, so the performance of Intel distribution of Python and Anaconda Python would be same. But if you're using something from the scikit-learn, which is being powered by Intel Data Analytics Analysis Library, this will be highly performant only on Intel distribution of Python. It's not on the Anaconda Python yet upstreamed. When you're accelerating machine learning, you might be using scikit-learn as a package, and this is being powered by Intel Data Analytics Acceleration Library. And underneath, there is a math kernel library for all the mathematical operations, and Intel threading building blocks for all the threading aspect. So you are able to get efficient memory layout when you're using Intel DAL with respect to numerical table, and which has a very good memory access, which gives you higher performance. This is also optimized for cache performance, and compute efficient operation is mapped from MKL. To give you an idea, the performance implication using scikit-learn with Intel DAL, which is powered by, this is comparing stock Python with Intel distribution Python with closing to the native code performance, which is C performance. You can see k-means predict and k-means fit, which is like uh, um, using the training and prediction. The prediction is 100% as your C performance. So we are very, very close to the C native performance, and you can see the stock. If you're using stock Python, you would not be getting any performance improvement. So we recommend in the Codeathon specifically, if you would like to have your performance aspect higher up, download Intel distribution of Python. It is free and free to use. There is absolutely no change of code, just you need to activate and use it. I will also show you how do you activate it. These are the numbers on EC2 instances with respect to scikit-learn from Intel distribution of Python. You can see on C5 18x large, there is a 266x performance when we are trying to run it on EC2 with AWS. When we try to accelerate k-means, there are multiple algorithms, random, PCA based. You can see it's 23 times faster compared to stock scikit-learn, and 22 times faster in k-means on stock scikit-learn. So you can get all this advantage when you use Intel distribution of Python. You can also use dal for pi as a package, which you can use all the algorithm which is available in Intel Data Analytics Acceleration Library. This library is written in C++, so when you use dal for pi package, you will get all the advantage of the C++ package underneath your Python code. And this is open source. So how you will call it, just to give an idea, you just say dal for pi is you can import it, and you can just say k-means.init. You can pass on the parameters here, and then you have to say just compute, and then you can say you can pass on the compute initial centroid, and k-means clustering algorithm will work for you. Similarly, if you want to use it on distributed environment, you need to just pass it as distributed as true. Similar way, you can call it from dal for pi. And the way you run your distributed Python is with MPI run. And underneath, you can use Intel MPI when you use dal for pi. Minus N4, that means you run it on 4 node. And with Python, you're running this Python file in distributed environment. Intel Python is powered by math kernel library. So all these linear algebra, your BLAST function, basic linear algebra solvers, your scalar pack, your iterative solvers, all being powered by Intel MKL. A lot of places in AI, we are using FFT. So you can get very highly efficient FFT, even multi-dimensional FFT, which is being developed in MKL, and this being powered within the Intel Python. The other library which I spoke about on the machine learning side, which was data analytics acceleration library. So when you develop your application, training is just one part of it, but the entire application goes through a complete channel of pipeline from your pre-processing step to transformation, and then analytics, and then you do modeling, validation, and decision making. Each stage has its own algorithm, which DAL has very efficient implementation, which you can directly use it if you're doing C++ development, or use dal for pi as a package when you use Python. So let me give you an idea what kind of algorithms available within DAL is for supervised learning. On the regression and classification side, we have logistic regression, rich regression, linear regression, and classification. We have Navi bias, KNN, and support vector machines. There are slight color coding I would like to mention. The boxes in light blue are the algorithm which are supporting batch, online and distributed processing, and where algorithm which is in white color are only supporting batch processing. The data transformation and analytics algorithm, you can do a correlation dependence, or matrix factorization, or dimensionality reduction using PCA. All these are algorithm is highly optimized and available within Intel DAL, and which you can also use it from DAL for pi package within Intel Python. To give you an idea about the acceleration of DAL, which is comparing XGBoost, a lot of people are using XGBoost. So on classification regression side, you can see on the training side, Intel DAL is almost like close to 12 times faster. On the regression side, it's close to 6 times faster. There are multiple services also available on AWS Market Place. You can use Intel Deep Learning Inference Stack, which allows you to have optimized deep learning. So when you download Intel distribution of Python, You can also download the Intel optimized TensorFlow, and this will be part of your deep learning inference stack. What I mean by Intel optimized TensorFlow is when you try to use normal TensorFlow and run it on CPU, you will definitely not get the performance best out of it because it's not written for CPU. So Intel has taken a goal to optimize all this framework. You name it, maybe TensorFlow, PyTorch, MXNet, and all these are being optimized by Intel to give you better and better performance out of the box. So you can deploy it, just install it using Intel optimized TensorFlow, and then pip install Intel TensorFlow. When you do it, you will get it Intel optimized TensorFlow, which is highly optimized for CPU. Similarly, BigDL is one such library which is which you can run it using Apache Spark, and there is a lot of there is also Analytics Zoo, which has lot of model which has been developed and deployed, which you can directly use it from the marketplace for running your distributed deep learning on Apache Spark instances. So with this, I would like to conclude my talk. Any question? I would would like to show you one small demo. If you can see my screen, how do you use Intel Python and what kind of performance you can get. So let me just show you a normal Python and Intel Python performance differences. So when I say Python, this is my normal talk Python 3.7, and I would like to use Jupyter Notebook to show you a demo. Please let me know if you can see my screen. So I'm trying to use the k-means algorithm, which is part of scikit-learn, and I will try to show you the performance implication. What I'm doing is I'm using, just to show the implication and the usage, I'm using one colorful picture of a China some temple which has 96,000 unique colors, and we try to quantize this color using k-means clustering algorithm. And for this I'm using only 8 colors to represent the same picture, and I'm doing quantization. So what I'll do is I'll just import the matplotlib just to draw the picture. Here I'm using NumPy, and then I'm using matplotlib, and then I'm using sklearn and clustering algorithm k-means. You can see I'm doing a pairwise distance, and now I'm trying to use n colors, which is 8 colors, and I will try to draw this picture. Here I'm using the NumPy array, converting this China image to 256 colors, and then putting height, width, and shape to NumPy array. Now I would like to do training and then inference. So I'm doing k-means clustering, number of colors is 8, and fit is nothing but the training of this algorithm. After this, within this, I'm doing a time, how much time it is taking for training and printing this. Similarly, I will do prediction, k-means dot predict, and then I'll try to do prediction timing here. Now it's running. You can see the star mark. It is taking some time to run this. You can see it is taken 24 seconds for training to fit this model, and 0.08 seconds to do the prediction. Now I would like to show you the picture, how the picture looks with respect to when you use random colors and when you use k-means clustering algorithm. This is the original picture of this china.jpg, which has a temple and 96,000 colors. This is the picture which used k-means algorithm and depicted only using 8 colors. And then this is the picture which we have also used 8 colors, but the random colors, not quantized using k-means. You can see this has taken 24 seconds to run it. Now I would like to run the same code with Intel Python. So I'll show you how do you invoke Intel Python, and there is absolutely no code changes which you're supposed to make. So now I will invoke Intel Python. When you download it and install it, it just comes as a zip file, and then you can just unzip it. You can keep it in any directory. I'm just keeping in Intel Python 3 directory, and then you can say scripts is a folder, and then inside that you have activate.bat. I'm running it on Windows, so .bat, and if you're running it on Linux, you can say just activate. Now when I say Python version, You can see this is Python version 6.5 Intel Corporation here. Now I would like to run the same Jupyter notebook from here, from Intel Python scripts, and then you have Jupyter notebook, and I'll open the same notebook. Which we have run, and now I will run with Intel Python. So there is absolutely no change of code. I'm using the same Python file here, matplotlib. I'm trying to use NumPy, matplotlib, and then cluster k-means clustering algorithm using 8 colors for quantization. This is, you're seeing a little bit of warnings because I'm using older version, so mread is deprecated but still works. In the newer version, it will be a different function which you can use it for reading the file. And now here I'm using the same k-means algorithm, fit and then k-means predict. Now you can see I can do the fit, which is training, in 3 seconds compared to 24 seconds which I was doing it with normal Python. Here it's only with 3 seconds, and the prediction is 0.06 second. There is absolutely no change in the code, and there you can also see the kind of accuracy or the printing the picture. This is the original picture. This is the k-means quantization using Intel Python, and this is with the k-means random. So you can get better and better performance without making any code changes, only activating Intel distribution of Python, and you can use it in your environment. You can see absolutely 8 times performance improvement just like that. And this is on just my laptop. When you run it on high-end servers, you will see even better performance, and then you increase the problem size. With this, I would like to conclude my talk, and if you have any questions, you can post so. Any questions? I'll stop sharing my screen. And I thank you for your time for attending this talk. Any questions, you can reach out to me. Yeah.
Thanks, Jyotsna. I think there are a few participants, but then no questions as of now. Those who are watching this session offline or right now, any questions can be asked even through the email help or the chat help available on Skillinza page. So please do post your queries, and we can also help you offline. Thank you all for joining, and thanks a lot, Jyotsna, for this session. It was very informative, and I'm sure it's going to help students come up with good ideas. So thank you.